Hi everybody. I'd like to introduce you to the basic topic of base conversion, or what is sometimes called radix conversion. The common bases that we deal with in computing include base 2, also known as binary, base 8, sometimes called octal, base 16, also known as hexadecimal, and then there's base 10, which is the common base, also known as decimal. So we've got binary, octal, hexadecimal, and decimal. There are an infinite number of different possible bases. Typically what we want to do is we want to convert from one base to another. And so what we'll do is we'll show some basic exercises in how to do base conversion. And we start with a thing called positional notation. And in positional notation, what we do is we write down the base, its coefficient, and then its exponent. So 3 times 10 to the 2 means we have a 3 in the second place. 2 times 10 to the 1 means we have a 2 in the first place. And 1 times 10 to the 0 means we have a 1 in the 0th place. And we denote this as 321 base 10. Similarly, if you change the base, 3 times 8 to the 2 plus 2 times 8 to the 1 plus 1 times 8 to the 0, you get something that looks similar, 321 base 8, but is really a very different value. In fact, if we think about it, 8 times 8 is 64. 8 to the 1 is equal to 8. 8 to the 0 is equal to 1. And so we have a completely different value now. Where 3 times 64 gives us a value 209 in base 10. So 321 base 8 is equal to 209 in base 10. So using positional notation, we can convert from base 8 to base 10.